Loyola Lions. In today's mini lesson, we're given the equation x equals 8, and we're going to use inverse operators to figure out what x actually equals. And we're going to check every box that is a true statement for x equals 8. Now this is number 24 of your Utah, page 160. So please follow along. This will help you with what you're doing today. Okay? So let's take a look here. What we can do is take each individual statement. Here I have x plus 5 equals 13. And what I want to do is find out, is this true for this? Now, what I want to do here is I could use an inverse operation. Now, you might be saying, well, I can just substitute 8 in and see that it's true. But I want you to learn to use your inverse operators as we go forward in algebra, because it won't always be so easy as just plug in the number. Okay? So, let's do it. I see that I have plus 5 being acted on x. So I'm going to minus 5. That's my inverse operator, as you can see here. So, minus 5. But if I do something in algebra to one side, I have to do it to the other. Minus 5. Now, I get 5 minus 5 is 0, so all that I'm left with on this side is x. And on this side I have 13 minus 5 is 8. And I have x equals 8. And x equals 8. It's true. So this one is a big old check. Yes! Now, let's move on to the next one. 3x equals 11. 3x equals 11. Okay, so what's being done to x is it's being multiplied by 3. So I need to undo multiply by 3. When I look at multiply and I look at the inverse operation, it's divide. So I need to divide by 3. So I'm going to say divide by 3. And I'm also going to say divide by 3, because if I do something to one side, I have to do it to the other. And these go away, and I end up with x equals 11 thirds. Is 11 thirds 8? It's not. It's not. So this one, no, can't be true. Okay, next. We have x divided by 2 equals 2. Now, remember, I want to do the inverse operation of what's being done to x. Here, I'm saying that this is x divided by 2, so I want to undo divide by 2. Why don't you pause the video and see if you can do this on your own? Are you back yet? X divided by 2, if I want to undo divide by 2, I need to multiply. You guessed it, multiply by 2. That's 2 times x divided by 2. But if I do something to one side, I have to do it to the other. And so, times 2. Now, we saw that we can cancel these out, and I end up with x equals 2 times 2 is 4. Uh-oh. Did it work? X equals 8. X equals 4. Nope. Okay, now let's try the next one. I have x minus 8 equals 0. Minus 8. What's the opposite of minus 8? Minus. Well, it's plus. So let's say minus 8, the opposite is plus 8. And if I do it to one side, I have to do it to the other. So I say plus 8. Now, minus 8 plus 8, these cancel each other out, and I've got x equals 0 plus 8, which equals 8. X equals 8, x equals 8. This one gets a check mark. Now, last one. We have 4x equals 2. What's being done to x? Well, it's being multiplied by 4. And I see that my inverse operator for multiply is divide. So the inverse operation of multiply by 4 is divide by 4. But if I do it to one side, I have to do it to the other. So I divide this side by 4 as well. Now we learned that these will cancel out, and I'm left with x on this side, and on this side I have 2 divided by 4, which we all know is 1/2. X equals 1/2. X equals 8. Are these true? And there's the answer to that first problem on your Utah page 160. Now work through the second problem. And be sure to make a copy in DocHub and upload it to Google Classroom. See y'all later!